Let us start with types of access specifiers in C++. We have seen inheritance, by which properties or members of one class can be acquired by other class. We have seen types of inheritance also. Now let us see how access specifier works in case of inheritance. Now there are three types of access specifier by which base class members are say derived by the derived class. Now type 1 here is inherit as private. So in the diagram you can see there is a class A which is base class and there is a class B which is derived class. But when this derived class is privately derived, what happens to the members of the base class? So private members of base class are not available to the derived class. So those are inaccessible. The protected members of base class will become private members of the derived class, and the public members of the base class become private members of the derived class. Now this is what the type 1 inherit as private. We are inheriting everything as a private. That's why this protected and public will become private members of derived class. So if this class A is having private members, those will not be accessible or derived by class B. But the members of the protected members and the public members of this class A will become private of this derived class. This is what type 1 is. Now let us go further with type 2. Type 2 is inherit as protected. Now on the base class A is there and a derived class is derived as protected derivation. Okay, so these private members are inaccessible. Those cannot be derived. The protected members, these are become protected members of the derived class, and the public members of the base class will become protected members. As the name is given, protected, so the public and protected members of class A will become protected members of derived class B, and private members will not be accessible by derived class. Okay, so the type 3 is nothing but a inherit as public. This is a commonly used inheritance access specifier for inheritance. So here the base class and the derived class. So derived class has three types of member: private, protected, and public. Private are not accessible or not derived, but the protected members will remain protected members of class B, derived class, and the public members will remain public members of derived class. So public members of base class are public member of derived class. Protected members of class A are protected members of class B, and private are not inherited. So this is what type 3 of access specifier, that is inherit as public. Now, this visibility mode specifies whether the feature of the base class are privately derived or publicly derived or protected derived. Okay, so public visibility mode says it means that the derived class can access the public and protected members of the base class. Now, if this question is asked that what are the access specifiers or visibility modes in C++, you have to explain this with the help of this tabular form, this diagram, as well as explanation which is written on this slide. Okay, so here the explanation which I have explained you with the help of diagram and chart is given here. So the public members of the base class become the public, and the protected member of the base class become protected of the derived class. Similarly, private visibility mode, the public and protected members of the base becomes private of the derived, and the inherited members can only be accessed through the member function of the derived class, as same as to the normal class operations. When we have protected visibility, the public and protected members of base class become protected members of the derived class. So let us see accessibility of base class members in the form of a chart. So access specifiers, we have public, protected, and private. So accessible from own class, yes, public members are accessible, protected are accessible, and private are also accessible when those are accessible from the own class. That means class A are having three members: public, protected, private. So class A members can access all three. What if accessible from derived class? Yes, public public members are accessible, protected members are accessible, but private members are not accessible from derived class. Maybe there can be any type of derivation. Okay. Then accessible from objects outside the class. The objects which are declared outside the class, yes, the public members are accessible, but protected and private members are not accessible from the objects outside the class. Okay. So this is the table to represent the visibility. Now next is visibility of inherited base class members in the derived class. So what happens? So visibility mode we have to the left hand side, public, protected and private. So public members of base class become public in case of public visibility mode. Protected members will remain protected in case of public visibility mode, and private members are not accessible. In case of visibility or derivation is protected, both the public and protected member become protected. So this is a summary of whatever we have studied. So in case of private, the public and protected members become private members of the derived class, and still private members of the base class are not seen. Now there are many important concepts which we should know when we implement the inheritance and when we talk about these types, that is visibility thing in the classes. So there is a concept called as a virtual base class. So this diagram is of multiple inheritance. You must be aware about the diagram here. We have a class A. Okay, so class B is derived from class A, and class C is also derived from class A. So suppose there is a function called as a tech, which is public function here in A. It will be derived to B as well as C. But if D is derived from B and C, then it will have a copy of same function through B. Whatever function is present in A, its duplicate copy will be present at B and C, and this D will be confused that with which function is a, say, main function, or which function should be called, or which function should be taken. So class D have duplicate sets of member inherited from class A. This introduces the ambiguity and should be avoided. Now why this ambiguity should be avoided? Because compiler will be confused in that case that which function should be called. So duplication of inherited members due to these multiple paths can be avoided by making the common base class as a virtual base class. Okay, so while we are doing derivation of this class A, uh, this class B will acquire properties of class A, that time declare it as a virtual derivation. Similarly, when this class C is derived from class A, that time we have to make it as mention that this class A is a virtual class. Now let us see by example, it will be easy to understand. Now see this program in which we have class A, it has a function in public section as show, and it is displaying hello from A. Now I have a class B which is derived publicly from A, class C which is again derived publicly from A. So this class B and C both are having copy of this function show. Okay, again this class D is derived publicly from B and C. So this D will have again multiple copies of that show function, and compiler will confuse that which function to call when it is called in the main function. Here you can observe the main function where the object of type D is declared and it is calling a show function. So here compiler will give the error. So to avoid this, what is a solution? Is a virtual base class. Now see the same example, small changes are done here. Now this is a class A, same class A which we have seen previously. Now we have a class B which is derived from class A, but here one keyword is added, that is virtual, public virtual A. Then class C, public virtual A. So whenever a class is derived from this B and C, it will have a single copy of that function which is common in all. So here just adding a virtual keyword while derivation, doing the derivation from A. Okay, for B and C. For D, we don't need to add that virtual keyword. So D is derived from B and C, and it will have only single copy of it. In the main function again, the object of type D is declared, and this show will call this hello from E. Okay, this is how it is resolved. The ambiguity is resolved using virtual base class. So this is what the first thing which we must be aware about. One more concept is there called as an abstract class. So class that serves only as a base class from which other classes can be derived, but no object of this base type exists is called as an abstract class. So there is an abstract entity which can be reused, and its own objects are not created and not used. Okay, so sometimes implementation of all functions cannot be provided in the base class because we don't know the implementation, what it will be needed at runtime or in the future. Such a class is called as a abstract class. So there are more terms related to abstract class, that is a virtual function. So a pure virtual function in C++ is a virtual function for which we don't have implementation. We have only declaration of it. Okay, so let us see example. Here we have an abstract class A. So there is nothing written like abstract keyword, so only class A, starting bracket, some data members will declare here. Then we have public section, and in public section here the keyword virtual we are writing virtual void display equal to 0. It shows that it is a virtual function and it will be overwritten by the classes which will implement this class. Okay, so this class will be inherited by some class B or C, and they will write the code for display. So right now it is kept as 0. So a pure virtual function is declared by assigning 0 in the declaration. Okay, so this is the example of it. Now below it can have other members. So this is what a terminology called as abstract class and a virtual functions. Okay. Now next concept we have is a friend class. So we have seen friend function before. So what is meaning of friend is who has access to the contents of the class. So similarly, if someone is friend of a class, then that friend can access contents of it. Okay, let us see how. The friend class A is a friend class can access a private and protected members of other class in which it is declared as a friend. It is sometimes useful to allow particular class to access private members of other class. Okay, so friend class, I'm not talking about friend function, it is a class. So it is other class which is friend of this class and can access private and protected members. So the friend class name, this syntax is granting a friendship to that class. So how? Suppose I have a class 1, okay, granting friendship to class 2. Then in class 1 I have to write this line, friend space class space name of the class. So friend is a keyword, class is a keyword, and class 2 is the name of a class which is friend of this current class, and a semicolon. So this appears in the class 1's definition. So this class 1's friend is class 2. So there are some properties for this friendship. So friendship is granted, not taken. So it is when this line is written, it is granted by class 1 that class 2 is my friend. And friendship is not symmetric. That means if if B is a friend of A, if B is a friend of A not necessarily a friend of B. Okay, it is not transitive. If A is a friend of B and B is a friend of C, A is not necessarily a friend of C. So it is not symmetric, not transitive. Remember this. Now let us see example how this friend class is declared. So here we have class A. Into that in private section we have integer, roll number and data, some members whatever are needed. Then we have friend class B. That means for this class A, this class B is a friend. This is what syntax of friend is. So today we will stop here.